we can use a triangle inequality to refine big O calculations, and this basically states that the shortest distance between 2 points is a straight line. So the length of edge C is always less than or equal to the length of edge A plus the length of edge B. And here is a triangle inequality where geometrically we're determining the distances between points or the length of the triangle edges. So we take the absolute values to make the comparison. And we can generalize a triangle inequality. So if we have the absolute value of A plus B plus C, that's less than or equal to the absolute value of A and B plus the absolute value of C. And continuing on, that's less than or equal to the absolute value of A plus the absolute value of B plus the absolute value of C. And now we can use the triangle inequality to show that the following function is ON squared. So we start off with the absolute value of the function, and by the triangle inequality, that's less than or equal to the sum of the absolute values of each separate term. So taking the absolute values, we obtain positive n squared plus 12n plus 12. And we know that this is less than or equal to n squared plus 12n squared plus 12n squared, which is equal to 25n squared. And by the big O definition, we have the function of n is less than or equal to some constant c by f of n. So in this case, f of n is n squared, c is 25, and t of n is our function. And if we quickly write this expression over here, we can see that this holds for n greater than or equal to n naught, where we can take n naught equal to 1. So we conclude that the function is ON squared. Please subscribe, like and comment to help me reach more students.